Okay, so we have our reports ready. These were generated by MultiQC. Before we open the MultiQC reports, let's look at the individual files that were generated by FastQC. So we will go to data and then we will go to FastQ. So let's open that. So you will see an HTML file and a zip file for each FastQ file here. So if we had specified 10 files, then each of the 10 files will have a report generated for it. So take note of that. Now let's look at the report for read 1. So let's open it. We will use our browser. So I'll double click and then my browser will open it for me. Okay, so we have our summary here. What you should know is that for every FastQC report, each summary will have one of 3 colors. So we can have a summary with this color, which is green. We can also have this, and also have this. If it's this color, that means everything is okay. If it's assigned this color, that means there's something probably wrong, so you have to check. It's a warning sign. If it's this color, that means something is really wrong. That's what you need to understand here. For this tutorial, I will focus on the per base sequence quality. That is what I will focus on. I will make another tutorial where I go into details with QC. So that's about it. So if you look at the per base sequence quality, you will see that they are all in this region. Again, we have our 3 colors here, this. If it's here, that means quality is very low. That means poor quality. If it's here, somehow. But if it's in this area, that means high scores, indicating good quality. And as we can see from here, all the base scores, all the scores, okay, the per base sequence quality scores, they are all, almost all of them are in this region. So that means the reads are okay, reads are good. That's about it. But you can also see some of them are moving towards this side, which is normal for paired and reads. You always have at the end, okay, having low quality. The quality reduces as you go to the end of the reads. So that's why you will see this. So if you have some reads, most of the time you will see that as it goes towards the end of that read, you will see it's dipping. The scores will be low. That's about it. Let's check the read 2. Okay, so let's look at read 2. Let's open this. And then we have that also here. Read 2, we also have a similar observation when it comes to the per base sequence quality. So it's also good. But then if you are dealing with lots of samples, then it's going to be very cumbersome trying to read each of these HTML files. And this is where MultiQC comes in. MultiQC will aggregate all the reports into a single HTML file for you. So that makes it easy for you to do your comparison as well, and then inspection. So let's open the MultiQC reports. So let's go to our main directory, which is variant colon, and then let's open this report. Okay, so we have that here. So it's the reports here that have been aggregated here. So that's what you need to know. So you have the mean quality scores here in this region, meaning everything is okay. Have this also here, everything is okay. So let's go to the Galaxy page and then look at some statements here. So it says that the sequence quality is quite good overall. If anything, you may have to trim the 3' ends of the reads. Okay, I made mention that towards the end of the reads, the quality declines. So that is why the Galaxy authors also recommend that you trim the 3' ends. But we will leave it as it is. Okay, because the reads in general are good. their quality is high, the scores are high, so we are dealing with quality reads, so we will leave them as they are. There's one thing we need to observe, so that is point 2. Let's look at it. This statement is very important. In whole genome sequencing, a non-normal distribution of the GC content of the reads from a sample is typically considered to be a hint at possible contamination. Okay. But here we are dealing with sequencing data from captured exomes, that is reads that are not representing random sequences from a genome, but rather a biased selection. So we are not using whole genome sequence, but we are using exomes. And this means that we are going to have a non-normal distribution of the GC content. That is what this means. So we have what a bimodal GC content distribution. Okay, that's what it's giving us here. So this indicates that what we are dealing with exome sequencing data, or we are dealing with exome sequence. That is what it means. So when you see a bimodal GC content distribution, it's a characteristic of exome sequence data. That's what basically this means. So let's check the QC reports again. We just want to look at what this document is referring to when it comes to the GC content distribution. So let's just look at the FastQC one, for example. This is what's talking about, where we have the red color. So that's the GC content. So this where we have this red color. So this red color, I made mention that it tells us that something is wrong. Okay, and here the color shows something is wrong, but this is because we are dealing with whole exome sequence data. That's what it means. We are dealing with exome data. Let me put it that way. We are dealing with exome sequence data, but FastQC probably is assuming that we are dealing with whole genome sequence data. That is why we have this color showing, indicating there's something wrong, but in reality there's nothing wrong. That is what this statement is explaining to us, that we are going to see a non-normal distribution of the GC contents. Okay, we are seeing a bimodal distribution. Okay, that is why FastQC is giving us this color here, telling us something, but there's nothing really wrong, just because FastQC is not able to identify that we are dealing with exome sequence data. It's giving us this color. When we check the MultiQC report, let's look at the GC contents here. We will have a similar thing. There will also be that red color. So that's what we have.